Hey guys, these are going to be our notes 4a.3 on triangle similarity. Pardon the whiteout. I had to start the video over due to interruption. So triangle similarity is going to be different than triangle congruency. Triangle congruency would be two triangles that are the same shape and the same size. Similarity is going to be the same shape, but we're going to have different sizes. One's going to be bigger, one's going to be smaller. So with triangle congruency, we talked about you cannot use the angles to prove congruency, but you can with your similarity. So here we're going to state that if two angles of one triangle are congruent to two angles of another triangle, then we are similar. Okay? So inside we'll look at three different examples saying, are they similar? If so, we want to write a similarity statement. So we have two different triangles. I'm not going to name them just yet because we have to make sure, again, just like we learned with congruent triangles and even with our quadrilaterals and polygons, our corresponding parts have to match in our names. So we see here that we do have one angle. That's going to be congruence, but we have to have another one to prove that these are similar triangles. Angle A is 26 and angle angle F is 64. So what we have to do is we have to figure out if angle C is also 64 and if angle D is also 26. So we can take our two angles here, 26 and 90, and we can add these two together, and we will get 154. When we take that 154 and we subtract it from 180, we wind up with 26, proving that angle D is going to be 26 degrees. So we can state that angle A and angle D are congruent, which is automatically going to tell us that angle C is 64 degrees. Okay, this is why sometimes you'll see it as angle, angle, angle similarity, because you have to use your triangle sum theorem to find the third angle. So since we are saying yes, these are going to be similar, we need to write a congruency statement. So if I name this triangle ABC, say first need to write yes, the answer to the first question. Yes. We will say triangle ABC. Here's our similar symbol. Okay. A matches up with D. So we'll say put the triangle in there. Triangle D. B, the 90-degree angle, matches up with E. And then C and F correspond. So we could say yes, triangle ABC is similar to triangle DEF. Okay. The triangle, the way this one is going to work is we can separate this into two different triangles. But first what we're going to do is focus on the fact that we have here parallel sides. We need to remember our angle relationship with parallel sides and transversals are not going to change. So since we have two parallel sides here, we could count this segment BE as our transversal. And right here, we're going to wind up with congruent angles. We have corresponding angles here. Another thing that we need to see is that we are going to have this angle up here, E, is actually going to be part of both triangles. And some of you may be able to see it and not need to see the triangles separately, but as visual learners, sometimes seeing them separately helps you understand what's going on with angle E. So what I'm going to do is I'm going to take a color and I'm going to outline this triangle and draw it off to the side. So here's angle E, R, and S. And that's supposed to look purple. It's a purple pen. And I'm going to take another color and I'm going to outline the entire huge triangle. Because what we have a triangle inside of a triangle. And then I will draw this one off to the side as well. Here we have E, over here we have B, and over here we have A. And we have already established that angle B and angle R are congruent But now you can see how both triangles, since we had a little triangle inside of a big triangle, they're going to share that top angle, and you'll see that quite often. So we can say, yes, these are similar, okay, because we've got right up here, angle E is congruent. Sorry. It's late on a Friday, forgive me. Angle E is going to be congruent to angle E. So here we have our reflexive property. We've got the same thing on both sides. And angle R right here is congruent to angle B over here. So we have two angles here now. So we could, and we also do want to claim right here that these two are corresponding angles. So therefore, we can conclude, yes, and we'll name it triangle. We go ERS is similar to triangle. E corresponds with E, R corresponds with B, and S corresponds with A. And there's our similarity statement. The last triangle we have here, what we need to notice is angle V over here has one arc. Angle D has two arcs. Angle C has three arcs. If you look at everything else going on, I don't see anywhere else where I see 1, 2, or 3 arcs. So we're not actually claiming that any of the three of these are congruent with any other angles. So what we have here, we already have to draw 4 arcs. We do have vertical angles, but that's the only set of angles we have that actually are congruent. So this is going to be a situation where we say no. We cannot claim that these are similar, and we'll say the only congruent angles are the vertical angles. Okay? We cannot say any other angles are congruent. Now, if angle U had 1, 2, or 3 arcs, then yeah, we could say it, but we don't have anything there. Okay? Next, we are going to look at our side similarities. Same thing with congruency. We can prove side, but because they're not congruent, the sides will not be the same. So we're going to have to use proportions and our ratios that we've learned previously. This states that if the lengths, hopefully I spelled that right, I always forget. If the lengths of the corresponding or matching sides, the lengths of the corresponding sides of two triangles are proportional, then the triangles are similar. Okay? So what's happening here is we talked about on the 4a.2 flippable that your angles are congruent but your sides are proportional. So we have to check that all three sides, if we take the ratios, when they all have to simplify to the exact same fractions or ratios. Okay? So I'm going to show you how I like to do this. When I have all three sides, here I'm going to have a small, medium, and large side. So this is how I work this out. I match up my small sides, my medium sides, and my large sides. So here I'm going to go ahead and look at my small sides. My small side on one is going to be it's going to be side or segment AM. So we'd have AM over its corresponding side. So how do I figure out which it corresponds? Look for the smallest side, HW. And if I look at that ratio, AM is 8 and HW is 4. And this will simplify. You always want to make sure you simplify these, okay? This will come out to 2. the medium sides, okay, the middle number. Here we have AL, and the middle one over here, the 6, HP. So we take AL, 9, and we take HP, 6. And we're going to simplify that. When we simplify this, we actually come out to 3 over 2. So honestly, we already know these cannot be similar because these are not proportional. But we're going to go ahead and work out the large side as well for practice. The large side, LM, over PW. LM is 12. PW is going to be 8. This will also simplify to 3 over 2. So we have 2 that check off proportionally. Problem is, do this in a different color pen. So these 2 check off as proportional, but the smallest side is not proportional. So we have to claim that no, these are not similar. And the reason why, to justify this, is only 2 of the 3 sides are proportional. Okay, so we cannot write a similarity statement. We also cannot write a scale factor because they're not similar. Okay? When we move over to the next one, we'll again take a look at the small, middle, and large, and we'll compare once we simplify them. So, if we take the small sides, here we have UJ over, the smallest number out of here is going to be that 4, so we'll have IT. We place the 3 over the 4, and it's already simplified. Let's take our middle one. So the 6, US, over, the middle one over here will be IN. So 6 over 8. This is going to simplify to 3 over 4. So far so good, but we have to check that larger side as well. And the largest one over here, JS. And we got JS over TN. So we have 12 over 16. This ends up simplifying to 3 over 4 as well. So the good news here, we can claim yes. And we have that triangle. And now we need to look at what order to go in. If I go J to U to S, triangle J, U, S is similar to triangle. I started off going from the small side to the middle side. So here I'm going to go small side T to I. So T, I, N. Okay, and we could say this is by side, which I didn't put on the angle one. It also wants our scale factor. Now we need to remember about scale factor with the previous notes. Here I was putting the first triangle on the left over the one on the right whenever I was looking over here. These are similarity statements, similarity ratios. Our scale factor, we need to remember your scale factor is always going to be your new over your old. And all you have to do is choose the small, middle, or large side, does not matter which one. We could take the small one here and here, remembering that this is our old one, this is our new one. So we'd actually have to put the 4 over the 3. This would be the scale factor. Okay? The last one, we look at side, angle, side. Okay? This is going to state that if an angle of one triangle is congruent to an angle of another triangle, and the lengths of the sides including these angles. So again, this angle has to be, the included angle has to be between the two sides, just like we talked about with congruent triangles. Okay? If the two sides that make this angle are proportional, then we can claim the triangles are similar by side angle side. So we're basically taking both of the first ones we talked, the first and second one, we're taking these and we're combining them. Okay, we just need one angle, we need two sides, but that angle has to be between the two sides. So let's look here. First example here, we are looking at, let's first look at our angles. As we see here, we have vertical angles. So our angle is checked off. We have the angle. We just need to find out the sides and if the angle is the included side. So here, the 9 and the 6, these sides connect to make this angle. Over here, the 8 and the 12 connect. So that angle is between the two sides. So as long as the sides come out proportional, we have side angle side. So let's take a look at this. This time we only really have a small and a large angle, side. So we'll take a look at the small side. Small side here, we have OT. We are going to compare it to the small side over here of OB. So we have 6 over 8, reducing to 3/4. The larger side, we have OK over OR. OK is 9, OR is 12. This will simplify to 3/4 as well. So our two sides are proportional. Okay? So we can say, yes, triangle. I'm going to go from O, go across the smaller side first, T, K. Triangle O, T, K is similar to O, go across the smaller side, O, B, R. And we can say by your side angle side similarity. A lot of times you'll see this too, just means side angle side similarity. So we need to do our scale factor. Okay? If we're going from triangle OTK to triangle OBR, which is the order this is in, we have to remember to put our new over our old. So we can go back over here, or we can just choose our sides. Here are our smaller sides. So your scale factor of new over old, the new one will take the 8 over the old corresponding side, which is going to be 6. Simplify it to 4/3, and there's our scale factor. Okay. The next triangle, next pair of triangles over here. Again, we're going to come over here and we're going to look at what we saw up here where we shared an angle, because we have a triangle inside of a triangle. So right here we automatically have our angle. And with your triangle inside of a smaller triangle inside of a bigger triangle like this, your sides right here, as long as it's these sides we're talking about, your angle is included. It would be side, angle, side. But we first have to figure out if these are proportional. Now, we have side AD is 15 and AB is 25. Over here, AE is 12 and AC is 21. So we could take a look at our smaller side. And if we do AE, because that's the smaller one, over, look at 25 and 21. 21 is the smaller, so AC. We have 12 over 21. 12 and 21 can both be divided by 3 to simplify down to 4 over 7. Now let's take a look at our larger side. We have AD over AB. Remembering that when we do our sides here, on every single side that we figure out the ratio, we have to keep the same triangle on the top and the same triangle on the bottom. So here, I've been putting the smaller triangle on top on both of them, the larger triangle on the bottom. Okay? Corresponding parts. So AD was 15 over AB of 25. When we simplify this, both of these are divisible by 5. We wind up with 3 over 5. So these are not proportional. So even though we have a congruent angle, we do not have proportional sides. So we need to claim, no, they're not going to be similar. Okay, we've got one side proportional and the included angle is congruent. I'm shorthanded, sorry. But the other side, the other sides, are not proportional. Okay, this should say one pair of sides. Okay, so since these do not come down to the same similarity ratio, we cannot say that this is going to be, these are going to be similar triangles. Okay, and that's that for 4a.3.